Good evening, everyone. Myself Dimash Kumar. I am student in PIT Vellore 2024 batch. Currently, I am in 6th semester IT branch, and today I am going to present my model for the flight delay prediction. Mainly, I have used PySpark library for this project. Now, let's start with our project explanation. Firstly, I have installed my PySpark library in my Jupyter. After that, I have imported the PySpark library. The PySpark library is mainly used for an open source distributing the computing frameworks and the set of libraries for the real time and the large scale data processing. After that, I have imported the NumPy. NumPy is a Python library used for working with arrays. It also has a function for working in the domain of linear algebra, Fourier transformation, and matrices. After that, I have imported a Spark session using the PySpark library. In the Spark session, it's an entry point to underlying the Spark functionality in order to programmatically create Spark RDD, data frame, and dataset. After that, I have imported the two classification which I have used below: decision tree classification and logistic regression. First, I have set the Spark session builder so that I can load the dataset. As let's talk about our dataset now. Our dataset contains the month in the form of integer like 0 for January and 11 for December. Then day of month 1, 2, 3, 4, 5, 6 to 31. Then day of week 0 for Monday and 6 for Sunday. Then carrier, the flight name, then the flight number, then the origin of the flight, then miles, how many miles it's traveling, the departure time, duration, and delay. After that, I have displayed the table. Now we have to check the data type so that we can use below. Then we will drop all the NAs from the delay so that we can clean our data set. Then we will convert our miles into the kilometers and add it in our data set and label them. Now we create an indexer which identifies the categories and then create a new column with the numeric index values for the carrier index and origin index respectively. Create an assembler object. We will assemble all the objects from our dataset and store it in our feature. Then we will have two columns, feature column and the delay column. Now we will use the first classification model, which is decision tree classification. As for the decision tree, it is a non-parametric supervised learning algorithm which is utilized for both classification and regression tasks. It has hierarchical tree structure which consists of root node, branch, internal nodes, and leaf nodes. First, I have split my dataset into the two portions: training dataset and testing dataset. For the training, I have given 80% of my dataset, and for testing the remaining 20%. Now we will use our decision tree algorithm. First, we will assign a variable, and then we will recall the decision tree classifier, which is an inbuilt function in our PySpark library. Now we will predict the accuracy and other matrices. First, we will calculate the elements of confusion matrix: true negative, true positive, false negative, and false positive, which will be labeled as 0 for the true negative, 1 for the true positive, 0 for the false negative, and 1 for the false positive. Then we have calculated the accuracy. The formula for accuracy is Tn plus Tp divided by Tn plus Tp plus Fn plus Fp. Now, as we can see, the accuracy for this model is 0.633%, which is not that much. So we need to increase a bit. So now we will use the logistic regression algorithm. As for the logistic regression algorithm, it is used to predict the probability of certain classes based on some dependent variable. In short, the logistic regression computes a sum of input features and calculates the logistic of the result. Using this, we will predict the recall and the precision. For the precision, the formula is true positive divided by true positive plus false positive, and for the recall, it's true positive divided by true positive plus false negative. Now the precision value is 0.64% and the recall value is 0.61%. Hence, we have compared both the algorithm for our flight delay prediction.